Okay, so if you made it this far, level 4s are a combination of what we did in 2.1 and what we're doing now. Rational exponents, as you can see, look a little funny because the exponents are fractions. So when you have an exponent that's a fraction, the top number will tell you the exponent, so how many times you're doing that group. The bottom number will tell you what type of root. So again, if you're looking at number 5a, our top number again tells us the exponent, the bottom number tells us the root. So it would look like this. I'm going to take the big square root of 44 over 9 to the first power. Now raising something to the first power doesn't exactly change it, okay, but I just wanted to write that just so you can see where the 1 came from. So now I'm going to work within the square root. 44 does not divide evenly with 9, so I'm just going to take the square to the top and then the square to the bottom. And 44 can break down into 4 and 11, 2 and 2. So this is going to be 2 square root 11, and the square root of 9 is just 3 with nothing left over. So you got 2 root 11 over 3. Now it gets a little trickier when you add in variables. So again, now we've got 2/3. So that bottom number tells us what type of root it is, so it's going to be a cube root of 8x to the 9th and then squared. So you can do one of two things. You can distribute this exponent to things inside the radical, or you can evaluate the radical and then square it. Either way is fine. I prefer to simplify the radical first and then square it. So that's what I'm going to do. So breaking down, I've got the cube root of 8 and the cube root of x to the 9th. And remember you're squared. So 8 is 4 and 2, 2 and 2. So you got a group of 2's. So 2 will come out with no root left over. And x to the 9th, you think 9 divided by 3 is 3 with no remainder. So you just have x to the 3rd that comes out. And now we're going to square that. So remember, this equals 2x to the 3rd times 2x to the 3rd. So it's going to be 4x to the 6th. For C, fraction looks the same. So remember, okay, cube root 5a to the 6th, b to the 11th, over 8a to the 12th, b to the 7th. And we're going to square that. I would simplify underneath the radical first if I could, and then do the radical, and then apply the exponent of 2. So within the cube root, I can't simplify 5 over 8, but I can simplify the a's, which will leave me a to the 6th in the bottom and a b to the 4th in the numerator. Now since I can't simplify anymore, I'll take the cube root of the top and the cube root of the bottom. Breaking down the cube root of 5 and the cube root of b to the 4th, cube root of 5 is just the cube root of 5, and the cube root of b to the 4th, 4 divided by 3 is 1, so there'll be a b that comes out with 1b left over. In the denominator, the cube root of 8 is going to be 2, and then a to the 6th with the cube root, 6 divided by 3 is 2, so a to the 2nd comes out, and there is no remainder. Now the last thing I have to do is distribute that 2 exponent. So I have b to the 2nd cube root of 5b times 5b, because I squared it, over 4, because 2 to the 2nd is 4, and a to the 4th. So further simplifying, you'll have b to the 2nd, the cube root of 25, b squared, over 4a to the 4th. And now you just want to make sure that you can't break down 25 anymore, or the b squared. If the exponent is smaller than the root, so since 2 is smaller than 3, I know that I'm as far as I can simplify within the variables. And 25 can only be broken down into 5 and 5, and I need a group of 3 in order to break it out. So this is your final answer. So if you made it to level 4s, good for you. Go ahead and try the practice now.